20 engine sensors that are currently wasting your fuel explained. So if your car is suddenly using more fuel than it used to, the issue might not actually be the engine itself. In most cases, it's one of these 20 sensors that most drivers never even check, and when just one of them goes bad, the ECU starts making the wrong decisions and ends up injecting way more fuel than the engine actually needs. In this video, we're going to cover all 20 sensors, one by one. And for each of them, I'll show you exactly what it does, how it works, where it's located, and what will happen if it fails, plus the easiest and simplest way to fix or clean it so you stop wasting money at the pump. There are timestamps in the description if you want to jump straight to a specific sensor, but I recommend watching the whole thing first because a lot of these sensors work together, and one faulty reading can throw another one off. To make everything easier to understand, I've grouped the sensors into 4 categories. First, we have the airflow and intake sensors, which basically tell the ECU how much air is going into the engine and what the conditions are like. Then we'll move on to the fuel and exhaust mixture sensors, followed by the timing and combustion sensors, and finally the transmission and drivetrain sensors. So let's start right away with the airflow and intake sensors. Mass airflow, MAF, sensor. The MAF sensor is basically the ECU's air meter. It tells the ECU exactly how much air is flowing into the engine at any given moment, so the ECU knows how much fuel it needs to inject to keep the air-fuel ratio where it needs to be. Most modern MAFs work on a very simple principle. They've got a little heated wire, or film, inside the sensor housing. As air flows over that wire, it cools it down. The more air you have, the more the wire cools down. The ECU measures that change and converts it into a usable airflow signal. It sounds simple, but without it, the engine has no idea how much fuel to inject. You'll usually find the MAF right after the air filter housing, somewhere before the throttle body. When it starts to fail or gets contaminated, the ECU starts getting incorrect readings and overfuels the engine. That's when you'll get a rough idle, hesitation when accelerating, and higher than normal fuel consumption. The good news is that most of the time it's just dirty. You can clean it with a proper MAF cleaner spray and restore the correct reading. If the reading is still off after cleaning, then the sensor needs to be replaced. Manifold absolute pressure, MAP, sensor. The MAP sensor basically performs a similar job, except instead of measuring the mass of the incoming air, it measures the pressure inside the intake manifold. From that pressure, the ECU can work out how much air is going into the cylinders and how much load the engine is under. So at idle, there's a lot of vacuum inside the manifold. As you accelerate and more air floods in, the pressure rises, and the ECU can adjust fueling accordingly. Because it needs to read manifold pressure directly, you'll always find the MAP sensor installed somewhere on the intake manifold itself. When it starts to fail, the ECU no longer has an accurate idea of how much load you're placing on the engine. The common symptoms are hesitation when accelerating, uneven throttle response, and poor fuel economy. The first thing to do is check for vacuum leaks or cracked hoses, because those can trick the MAP into giving false readings. After that, clean the sensor port, and if the readings are still erratic, the sensor itself needs replacing. Intake air temperature sensor. The IAT sensor tells the ECU how hot or cold the incoming air is. That might sound like a small detail, but it actually has a direct impact on how much fuel the engine needs. Cold air is denser and contains more oxygen, so the ECU needs to inject more fuel to match it. Hot air is less dense and requires less fuel. Without an accurate IAT reading, the ECU can't make that adjustment and ends up running either too rich or too lean, both of which waste fuel. The IAT sensor is often built right into the MAF sensor, but in some cars, it's placed separately in the intake duct somewhere before the throttle body. A failing IAT typically causes poor cold starts and slightly off fuel mixtures, especially during extreme temperature changes. Fixing it is usually as simple as reseating the connector or replacing the sensor entirely. They're cheap and very easy to access. Throttle position sensor. The TPS monitors the exact angle of the throttle plate, in other words, how much you've opened the throttle when you press the accelerator pedal. The ECU uses that information to determine engine load and decide how much fuel to inject and when to advance or retard the ignition timing. If the ECU thinks the throttle is barely open when it's actually half open, it won't inject enough fuel, and the engine will stumble. If it thinks you've floored it when you haven't, it'll dump in unnecessary fuel and waste it. You'll always find the TPS mounted directly to the throttle body, because it needs to read the physical movement of the throttle shaft. When it starts to fail, the engine will often respond unpredictably to throttle input. Sometimes it hesitates, sometimes it surges, and the idle tends to become unstable. The easiest way to confirm is with an OBD2 scanner that shows live data. If the output is erratic or jumps around while you press the pedal smoothly, the TPS needs to be adjusted, if adjustable, or replaced. Now moving on to the fuel and exhaust mixture sensors. First, the oxygen sensor. The oxygen sensor plays a massive role in fuel economy because it tells the ECU how much oxygen is left in the exhaust gases after combustion. From that, the ECU can tell whether the engine is burning too much fuel, running rich, or not enough fuel. It constantly adjusts the injection in real time based on the sensor's signal, which is why even a slightly slow or contaminated O2 sensor can make the ECU dump extra fuel just to be safe. You'll find it threaded into the exhaust manifold or exhaust pipe, usually before the catalytic converter. When it begins to go bad, fuel economy drops, the check engine light comes on, and in some cases, the engine starts to run rough. If the sensor is just dirty or covered in soot, you can sometimes clean it and regain proper response, but in most cases, replacing the sensor is the safest and most reliable fix. Fuel pressure sensor. The fuel pressure sensor measures the pressure of the fuel in the fuel rail. Now, that might sound obvious, but that pressure directly determines how much fuel is delivered every time an injector opens. If the sensor is telling the ECU that the pressure is lower than it actually is, the ECU will automatically increase injector pulse width and, you guessed it, start wasting fuel. These sensors usually sit directly on the high-pressure fuel rail, and when they begin to fail, you'll see symptoms like hard cold starts, bogging under load, and a noticeably rich mixture. The first step here is always to check the actual fuel pressure using a gauge. If the pressure is fine but the ECU still reports a fault, the fuel pressure sensor itself needs to be replaced. EGR valve position sensor. The EGR, or the exhaust gas recirculation, valve helps the engine run cooler and more efficiently by feeding a very small amount of exhaust gas back into the intake during cruising. The position sensor tells the ECU how far the valve is actually open. If the reading is off, the ECU might close the valve too much, and that leads to higher combustion temperatures and increased fuel use, especially when cruising at a steady speed. You'll find the sensor mounted on the EGR valve itself. When it fails, the most common symptom is poor fuel economy on highways or steady speed driving, and sometimes even pinging or light detonation. Most of the time, it's not the sensor that's faulty, it's a carbon-clogged EGR passage that prevents the valve from moving properly. Cleaning the valve and the passages usually solves it. If the valve moves freely but the reading is still off, then change the position sensor. EVAP pressure sensor. This sensor monitors pressure in the EVAP system, which is the part of the fuel system that captures and recycles fuel vapors instead of letting them escape into the atmosphere. It's usually located somewhere near the charcoal canister, close to the fuel tank. When it fails, the ECU can't properly check the system for leaks, so it often assumes there is a leak and starts compensating by adjusting the air-fuel ratio. The most common symptoms are a rough idle, a strong fuel smell near the vehicle, and sometimes a random check engine light with EVAP system leak codes. Because EVAP is a sealed system, you need to inspect the hoses and lines for cracks first. If everything looks solid and the pressure reading is still wrong, then the EVAP pressure sensor needs to be replaced. Fuel tank pressure sensor. The fuel tank pressure sensor does something very similar, but it sits right on top of the fuel tank and constantly monitors tank pressure. That way, the ECU can tell whether the EVAP system is holding pressure or if there's a leak. If the sensor gives a false reading, for example, it thinks the tank has a leak when it doesn't, the ECU will again start compensating by enriching the mixture, which wastes fuel and usually triggers the check engine light. This one is a bit harder to access because it's often part of the fuel pump assembly. Failure symptoms include fuel smell near the rear of the vehicle, EVAP-related check engine codes, and slightly higher fuel consumption. If the hoses and seals are in good condition, the only real fix is to replace the sensor, or if it's integrated, the seal/pump unit it's mounted on. Now we are the three groups here, which is engine timing and combustion control sensors. For this category, we have first the crankshaft position sensor. The crankshaft position sensor is one of the most important sensors in the entire engine. It tells the ECU exactly where the crankshaft is at any given moment so it can fire the spark plugs and inject fuel at precisely the right time. If this timing is even slightly off, combustion becomes inefficient, which immediately leads to higher fuel consumption and, in many cases, engine stalling. Because it needs to read a trigger wheel that's physically attached to the crank, the sensor is always located close to the crank pulley, flywheel, or timing gear. When it begins to fail, you'll often notice random stalling, rough acceleration, or even sudden no-start conditions. Unfortunately, this isn't the kind of sensor you clean or adjust. Once it starts failing, the only reliable fix is to replace it. Camshaft position sensor. The camshaft position sensor does almost the same job as the crank sensor, but for the camshaft. It helps the ECU keep track of what each cylinder is doing, and is especially important on engines with variable valve timing or sequential fuel injection. Without an accurate cam signal, the ECU starts estimating, and that usually ends up wasting fuel. You'll typically find it mounted near the top of the timing cover or directly on the cam gear itself. If it goes bad, you'll notice a rough idle, poor acceleration, and a measurable drop in fuel economy. The sensor can fail internally, but in many cases, the problem is simply a loose connector or broken wiring. So always test the wiring first, and if it still doesn't send a valid signal, replace the sensor. Knock sensor. A knock sensor is basically a small microphone bolted to the engine block, and its job is to listen for abnormal combustion, also known as knock or pinging. When the ECU hears a knock through the sensor, it retards ignition timing slightly or adds more fuel to prevent damage. But when the sensor itself fails, the ECU often assumes the worst, so it pulls timing and enriches the mixture as a safety measure. That reduces power and burns more fuel. It's always mounted somewhere on the engine block, usually right in the center, where the knock signal is most intense. If the engine suddenly feels sluggish or inefficient and there's a knock sensor code stored, check the mounting torque first. A loose knock sensor can't detect knock accurately. If it's torqued correctly and still throwing codes, replacement is the next step. Engine coolant temperature sensor, ECT. This is the sensor that tells the ECU when the engine is warmed up. As long as the engine is cold, the ECU keeps the fuel mixture rich to prevent stalling. Once the coolant reaches operating temperature, the ECU switches to a normal, leaner mixture for better efficiency. If the ECT sensor fails and keeps telling the ECU that the engine is cold, even when it isn't, the engine stays in cold start mode and continues dumping extra fuel. That's why a faulty ECT sensor usually leads to high fuel consumption and black exhaust smoke, even though the engine feels like it's running fine. You'll find it threaded into a coolant passage near the thermostat housing. The fix is very simple and can be done by almost anyone. Unplug the old sensor and screw in a new one. No special tools required. Ambient air temperature sensor. The ambient air temperature sensor measures the temperature outside the vehicle and feeds that information to the ECU. Compared to other sensors, it's a small input, but it allows the ECU to make minor corrections to the fuel and ignition timing based on outside temperature. If the sensor is reporting the wrong value, for example, it says it's freezing cold when it's actually warm, the ECU may enrich the mixture slightly and increase fuel use. It's usually located in the front bumper or grille area, exposed to outside airflow. Once it starts sending incorrect or frozen readings, the best solution is to replace it. They're cheap, easy to access, and rarely worth trying to repair. Now moving to the final category sensors in this list, the transmission and drivetrain sensors. Vehicle speed sensor. The vehicle speed sensor basically tells the ECU and transmission control unit how fast the vehicle is moving. That information is used to decide exactly when to shift gears. If the signal is slow or inaccurate, the transmission usually delays shifts, which keeps the engine at higher RPM longer than necessary and burns more fuel in the process. Most cars have the VSS located either on the transmission housing, reading output shaft speed, or built into the wheel hubs. When it starts to fail, you'll experience late or erratic shifting, or the transmission might hold onto lower gears longer than it should. At that point, there really isn't a cleaning or calibration option. The sensor should just be replaced. Transmission fluid temperature sensor. This sensor measures the temperature of the automatic transmission fluid, and that temperature determines how and when the transmission shifts. When the fluid is cold, the transmission delays upshifts to help the fluid warm up faster. When it's at operating temperature, it shifts normally. If the sensor thinks the fluid is still cold, even when it isn't, it keeps delaying shifts unnecessarily, which increases fuel consumption and causes harsh, lazy gear changes. The sensor sits inside the transmission pan, in direct contact with the fluid. If you notice harsh or inefficient shifts and the fluid level and condition are okay, the temp sensor may be sending incorrect data. The best fix here is to change the ATF, fresh fluid improves accuracy anyway, and replace the sensor while the pan is off. Accelerator pedal position sensor, drive-by-wire. On modern vehicles, there's no physical cable between the accelerator pedal and the throttle body. Instead, the pedal has a sensor that tells the ECU exactly how far you're pressing the pedal. From that information, the ECU opens the throttle body electronically and decides how much fuel to inject. If the pedal sensor starts lagging or sending incorrect voltages, throttle response becomes unpredictable and fuel consumption goes up because the ECU can't match pedal input accurately. You'll find this sensor integrated into the pedal assembly itself. Common symptoms are delayed throttle response, hesitation, or situations where the car feels like it's accelerating more than you actually asked for. The fix is to recalibrate or replace the pedal sensor. There's no cleaning option. Wheel speed, ABS, sensors. These sensors measure the speed of each wheel individually. While their primary job is for ABS and traction control, many newer ECUs also use that speed data to fine-tune transmission shift logic and activate fuel-saving features like cylinder deactivation or coast mode. If one of the wheel sensors fails or gets dirty, the ECU loses that precise information and simply disables the smart fuel-saving strategies altogether. You'll find them on each wheel hub, pointed at a toothed tone ring or a magnetic target. Failure signs are a traction warning light on the dashboard and a subtle loss of fuel economy because the car goes back into safe mode. Often, the fix is as simple as removing dirt or metal shavings from the sensor. If that doesn't restore a clean signal, the sensor needs to be replaced. Steering angle sensor. The steering angle sensor tells the ECU how far and how fast the steering wheel is being turned. That's important for electronic stability systems, but it's also used by vehicles with electric power steering to reduce the load on the engine. If the sensor reading is wrong, the electric power steering motor may work harder than necessary, which puts extra load on the engine and causes a very slight but constant decrease in fuel efficiency. It's mounted inside the steering column, usually right behind the steering wheel. A failed sensor won't necessarily cause noticeable drivability issues, but you'll often see a stability control warning light and notice a small drop in fuel economy. The solution is to recalibrate the sensor with a scan tool, and if calibration fails, it has to be replaced. What to do next and how to stop wasting fuel. Step 1. Diagnose what's actually failing. The first thing you want to do is plug in an OBD2 scanner and check for stored trouble codes. Even a cheap scanner will usually point you in the right direction. Don't ignore the codes. They tell you which sensor the ECU is currently having a problem with. If you don't have a scanner, most auto parts stores will scan it for you for free. While you're at it, look and listen. Is there a rough idle? Hesitation? Poor cold starts? These symptoms often line up with very specific sensors, and matching the symptom to the stored code makes diagnosis a lot faster. Step 2. Stabilize the system and prevent further damage. Once you have an idea which sensor might be failing, check the basics first. Make sure the engine oil level and coolant level are correct. Top up if necessary, because low fluids alone can trigger a lot of the symptoms we covered: overheating, rough idle, wrong air-fuel corrections, limp mode, etc. If the engine is overheating, don't keep driving. Turn the heater on full blast to pull heat from the engine and get to a safe spot. Before replacing any sensor, Also check the connectors and wiring because a loose or corroded connector can cause the sensor to send the wrong signal even if it's still perfectly good. Step 3. Replace faulty sensors and stick to preventive maintenance. When you've confirmed a sensor is actually faulty, replace it and clear the codes. Most of these sensors are plug-and-play and can be replaced in a matter of minutes. Once that's done, build a simple maintenance routine. Clean the MAF every few months. Keep the throttle body clear of carbon deposits, replace the air filter on time, and monitor coolant and transmission fluid temperatures so you don't fall back into a rich running condition again. It sounds simple, but it's those basic steps that keep the ECU happy and keep your fuel consumption right where it should be. Now, before you go check this other video here, where I show the 2 ways to clean the oxygen sensor without even removing the sensors here. I will see you there.